Okay, so finally, good morning, guys. Good morning, everyone. Good morning, Sakshi, and thank you for joining. And please the excuse, we started out a little bit late today. We're dealing with some technical part of difficulty, nonetheless. Okay, so today, guys, as you all might be quite well aware of, simultaneously the classes are being conducted on YouTube too, just on a promotional level. I hope you are checking out all the videos, guys, that we are uploading. Okay, so basically, guys, today we are going to be covering up a very important and a very easy topic. You could call it is the most easiest topic that you can ever come across in mathematics. Why? Because it is easy to understand. I'm talking about the topic of matrices, guys. Matrices and determinants. This usually is an topic which you can expect questions from on the basis of applications in the sense equations topic, and in quadratic equations you'll be able to come across the questions and problems with respect to the method of matrices. Nonetheless, guys, today we'll be discussing about refreshing. I would add out the term because you already know what matrices are, but nonetheless I'll try to add in some extra points on my behalf, and I'll also suggest you the pointers which are important for your PGCET examination that will be asked by the KEM. Alright, initially, guys, to those friends of mine who are simultaneously watching me on YouTube, do subscribe to our channel, guys, at Rio Academy. Check out daily the YouTube classes. We have also uploaded certain previous videos for PGCET MCA and also for MBA students. Go through those classes, like those videos, guys, if you're able to understand. If you have any comments or suggestions on your behalf, do let us know in the comment section. Alright. Yes, good morning, Sakshi, and good morning once again to all my friends. Okay, so previously, guys, we have completed up the the most important topics of trigonometry and inverse trigonometry. Yesterday, in the previous session, we have solved out a number of questions related to the sense of inverse trigonometry. I hope you are able to understand them, but if you are for some reason have any part confusing or are much likely on a negative basis, do let us know, guys. So today, before starting up with the class, guys, let me inform you something regarding myself. So I'm an engineer, guys, professionally, as you might be quite well aware of. To those among you, let me inform, I've been an educator. It's been about for 6 years now, more than 6 years. So I'm an educator by passion, guys. Teaching aspect has been an interesting thought over me, and that is the reason I have been conducting the classes at the platform of Rio Academy, and I hope that I am being helpful to each and every student who is watching me. So coming back to our topic, guys, of matrices, and do join in, guys, at WhatsApp group, and then simultaneously also on the Telegram channel. The links have been given out in the description, and a number of students asking, guys, the classes are going to be conducted on an online basis. Online, the classes are being conducted both for PGCET MCA and also for MBA students. For that, you'll have to download up the app, guys. Download the Rio app from Google Play Store. You can join in the batch course of MCA or MBA that you like, that you want, and all the classes definitely will be available to you on a recorded basis, not just once or twice, guys, and there is no limited period or limited number of time that you can watch them. You can watch them as many number of times as you like. And if you have any furthermore questions with respect to the part of the courses being conducted, you can let us know. Alright, so do like the videos, guys. Once again, let me inform you if you're able to understand. Okay, so now, guys, see, basically so we have dealt with one particular topic, guys, which is known to be sequence or sequences. We have already covered up through this particular topic also. And in this topic, guys, as you all remember, if there are a set of data, if there is a set of data, or suppose let me take in an example of an organization or a company. Suppose let me take in the example of TCS. Okay, Tata Consultancy Services. Here let me assume that there are about 1 lakh employees who are working. Definitely there are more than that, but let me just assume there are 1 lakh people or 1 lakh employees who are working currently at TCS. So we have to arrange all these 1 lakh members, right? Arrangement is really important. Why do we need to arrange? See, arrangement is very important, guys, because there needs to be an social order. Without order we cannot be able to do anything. While we were kids, or while you were all kids, I still am, you usually used to think about, guys, whenever I want I'll take an holiday, whenever I want I can do anything. That is the thought that comes to each and every mind. We can't do that. Why? Basically holidays have been declared only on Sunday, and we have declared certain working hours and working days and duties with respect to each and every work. That leads to social order. Why social order is important? Social order is important in order to carry out the work. If work needs to be done, we need to have a methodology, we need to have some rules on the basis of which we'll have to follow it out. Each and every person has his own different mind. If we keep on doing whatever we like individually, then it will be a problem or a trouble to the other person. This world belongs to everyone. If tomorrow morning I get up, or today itself, I just say that I'm going to burn out the entire world, of course I can do that, but it is going to harm others also. It's not just my world, it belongs to each and every person. So we will all have to think out on a common basis, and to do that we have set up an order, especially an social order with respect to the sociality, and also we require the same order in case of each and every work. And in case of mathematics, guys, that order basically has been created in form of sequences, as we have seen in our topic. So as I was talking about, there are 1 lakh employees. So what are their working hours? How much salary should we pay them? How much leaves have they taken out? And what is their effective performance? On the basis of all that, we will be able to decide the development, or we will be able to decide the growth of this one particular organization, or the reasons and so on. And we need to arrange them. That's the reason why we need to arrange this data. We are going to arrange all these 1 lakh members. We are going to arrange them in many different forms. There are different ways we can arrange them. One such method that we have come across is sequences, in form of sequences. We are not going to do anything. We are just going to write down all these elements here. All the data we have been writing, we'll keep on writing them accordingly, one after the other, one after the other, one after the other. So such arrangement is known to be sequences. And here once again, guys, I can't keep on writing it as per I want, because other person also needs to understand it. For that reason, once again, here we have created the roles, and there are 3 basic rules here. Either we can arrange them according to the arithmetic progression, or geometric progression, or harmonic progression. Now the question comes, what do you mean by AP, GP and HP? That we have dealt with, guys, and I hope you already know that. Okay, now the second part, guys, of arranging, the second method, it comes to easy method, and that is just about the tabular arrangement. Tabular arrangement, it means we can keep on arranging everything just in form of a table, in form of a table. Okay, for example, I'll write down the name of the first employee. Suppose it is Ram, and I'll write down the details. Ram, he has attended about 28 days, he has taken 2 leaves, and he has done this work, he hasn't done this, and so on, so on, so on. We'll be able to get that data. And I'll take in the second name, I'll take it as Rahim, and I'll take in some data of his particular values and interest. So we can just keep on writing and writing just in format of a table. Okay, this once again, guys, is a form of arrangement. What's this arrangement? Just a table. We are not focusing on the alphabetical order, we are not focusing anything, just in form of a table we have taken down all these values. So we can arrange data also in the tabular format. And the third part comes to, guys, the arrangement in form of matrix, or in form of matrices. Okay, matrix, it too, guys, is a form of tabular arrangement. Matrices or matrix, matrix singular, matrices plural. ತುಂಬಾ ಜಾಸ್ತಿ ಬಂದರೆ matrices ಅಂತ ಹೇಳ್ತೇವೆ. So matrix is also an tabular arrangement. In the form of table only we arrange on the elements, but the only additional part from the direct table arrangement is we are going to arrange the elements here both horizontally and also vertically, right? In the case of matrices case, we arrange the elements both in horizontal format and also in the vertical format. Though the horizontal format here, the elements, we call them to be rows. Horizontal arrangements, we call them to be rows. For example, 1, 2, 3, 4. These are the horizontal arrangements. And then vertically, if you arrange them, for example, 1, 5, 6, 7. Okay. This form of setup is known to be a matrix. So vertical arrangement is known to be what? Because that is known to be columns. Alright. Rows and columns. So matrices, basically you can say matrix is a form of a table in which the elements are arranged both horizontally and also vertically. Alright, that is the only difference in between matrix and tables. Tables have only one directional, they are unidirectional. Either you can take rows or either you can arrange them in column format. But in case of matrix, you can take both these. Okay now? Now guys, these are very basic things, but there are certain more important points here. That is what I'm trying to say. What's that important point here? See, whenever it comes to order of a matrix, we usually go up around with row, number of rows and number of columns. Correct? Suppose I have a matrix. Suppose I'll take in matrix here, for example, a matrix A. 1, 2, 3, 4. Alright. So here there are two number of rows, the first row and second row, horizontal seatings 2, and then there are two vertical seatings, 2 columns. So 2 multiplied with 2. Always remember, the order is represented. First it comes to the number of rows, then it comes to the number of columns. Okay. Now the question comes, why are we writing the order? Why do we need this particular order? Edike beku order namge. See here. If I write down as per I want, if I take in the number of columns first, I'll suggest in one more matrix here. 1, 2, 3, 4, 5 and 6. Okay, I'll just write down one more matrix. And here guys, in this case there are 3 number of columns, 3 vertical setup or arrangement, 1, 2 and 3. So there are 3 columns and then there are 2 rows, right? So 3 into 2. If I take in the order of the matrix to be 3 into 2, then the person who is going to look at this value, how should he understand which one is column and which one is row? Because it might be anything. 3 can be anything, 2 can be anything. So we can't just take on as per we want. We have once again fixed some standards guys, and according to those standards we have taken the number of rows first and number of columns second. Why rows first? Just logically guys, we have just taken it out. Okay, so either wherever you go, you have to follow this order. Always the first element will represent the rows number and the second element will represent the column number. Okay, in case of order. So this setup guys that has been represented here is known to be order of a matrix. Alright, now the question comes, what does this order represent? The question comes here, what does this order represent? Why do we need to show the number of rows and why do we need to show the number of columns? See, basically guys, suppose there is a registry. There is a registry of, let me say, an institute and registry of attendance sheet. On that registry, if I just say in there are totally 100 students, that is over. Correct. If there are 100 students, then it is over. Then I am going to check out furthermore who attended how many classes and who did what and so on and so on. We are not concerned about that. Registry gives us the total number of students, or in this case, mathematically speaking, it will give us the total number of elements. Okay. Okay, so I think Sakshi has a doubt. Okay, Miss Sakshi, if you got doubt, you can just raise your hand, ma'am. Or you can also let me know in the comment section. Okay. Okay, see you guys. Okay, fine, ma'am, not a problem. Okay, I was talking about an example of a registry, right? Registry of an attendance sheet. So how many students are there in this particular institute? If I ask, you can just directly say there are 100 number of students, right? This is basically the data that we are looking for. As I told you, matrix is also a form of tabular arrangement. All right. Even if I arrange the elements in both horizontal and vertical format, rows and columns, I am only considered about this number 100. Suppose I taken the number of students in an institute to be in a matrix format. There are 100 students. If I do it tabular format, like a registry format, definitely I'll be able to know 100 students. If I do it in matrix format also, I should always consider the data of 100 students, right? So basically what I only want the number of students. But whenever we represent the matrix, we always represent it with the help of order, correct? Order of a matrix. We always say order of a matrix. We don't say number of elements in a matrix and so on. We always say order of a matrix. And even in sequences, guys, we always say number of elements. We have seen that. Suppose in case of arithmetic progression, small n, it represents the number of elements, and there is also a formula, Tn is equals a plus n minus of 1 into d. Within this formula also, we are only concerned about number of students if you want, in sequence format also. In case of registry too, in case of tabular arrangement also, we'll definitely get out the number of elements n. But when it comes to matrix, we don't say number of elements, we say order of matrix. Why is that important? And what will this particular order give us? See guys, order is nothing but the second name. You can call it as a synonym for the number of elements. See, basically what we do here, in case of a matrix, there are how many elements here? Basically on counting basis, 1 2 3 4 5 6, there are 6 elements, right? So here in case of matrix, we represent that number of elements on an multiplicative basis. See, there are number of rows 2, number of columns 3. 3 into 2 will give us what? It will give me 6. So basically guys, this order, if you write down the furthermore value, you will just get the number of elements itself. This is nothing new, just the same value. We are writing it down into form of number of rows and columns because we should know how many number of rows are there and how many number of columns are there. If we directly write in the number of elements as 6, then we won't be able to know how many rows there are and how many columns there are. In order to specify that, we just write these number of elements n into a previous format. We'll just take them to be a multiplicative form of a row and a column, right? Suppose if I take in another matrix, A to be equal to 1 4 5 6 7 8 and then 9 2 and 3. Okay, here the number of elements are how many? There are totally 9 number of elements. If I just directly write in n number of elements to be 9, I won't be able to know how many rows there are and how many columns there are. So basically, in order to represent also the number of rows, also the number of columns, and also the number of elements, we basically go out with the order. There are basically 3 rows and 3 columns. Okay, so we don't write down the answer guys next, because this much is sufficient. 3 into 3, 9. That will be easier for us. Okay, so that is the basic use of number of rows and number of columns, just on a representative basis. This guys is nothing new that I have told you, but number of students basically don't think about. We don't usually think about. Mindset has been created in such a way that we only focus on getting out the results, and that too on an aspect of percentage basis. Okay, so I hope this is clear guys. The number of rows and number of columns perspective. Of course, this just has been an a refreshing idea. Okay, so always remember guys, order represents the number of elements, number of rows at the first row and number of columns at the second row. Okay, that is it, and that is guys the basics that you needed to know entirely about what matrices are. Okay, now so now we are going to deal about guys with the different types of matrices. Okay, different type of matrices and order of a matrix guys. we can arrange as many numbers we want. In case of matrices, we can take in 101 number of rows, we can take in 200 number of columns. Basically we have seen order of matrix to be what, 2 cross 2, or maximum basis we go out with what, 3 cross 3 matrix. Apart from this, we haven't gone in our studies 4 cross 4 matrix, or 5 cross 5 matrix, or 10 cross 5 matrix. These kind of matrix also do exist, but we haven't studied them. At max we only look up to 3 cross 3. Why? The question comes, because what we do, guys, whenever these larger matrices, we try to avoid it out. Why? Because 4 cross 4, first of all, it will be a large number. Calculations will turn out to be what, very much on a difficult basis. So as far as possible, we basically try to bring out everything into a shortest form as far as possible. So the shortest form on a maximum basis is 3 cross 3 matrix. Okay, and then if you want, we can also bring it out to 2 cross 2 matrix. How should we bring that, sir? That you are going to learn out, guys, on the basis of various topics that you are going to be studying. For example, on a research basis, if you want to study something about cosmos, okay, outer space, and you want some data, you have to think of such a method that you can bring that data in form of either 2 cross 2 or either in form of 3 cross 3 matrix. You'll have to think for that, and that thinking part you are going to learn about in the part of physics or astrophysics. Okay, that we are not concerned about. Okay, we are just here to look at the part of the application part of how a matrix is going to work out. All right. So I hope that is clear, guys. If you got any doubts or any questions with respect to matrices, you can ask. Even for your PGCET examination, that is all that you need to know. Basically, guys, in your PGCET examination, you can expect the questions on matrices, one-liner questions, like on the basis of types of matrices, on the basis of rules of matrices, inverse of a matrix. Okay, what happens when you go out with the associative laws of matrices, distributive laws of matrices, and so on. And then apart from that, you can expect the solving part of questions with combination of equations and matrices. We'll come back to that furthermore. So now, guys, basically we'll look at types of matrices. I hope it is visible. See, I've just taken out the PDF format, guys, of types of matrices, because as you all know, you too know it, and again I'm just going to go through it on a refreshing basis. Okay, so first here, guys, row matrix. A matrix having only one row is called a row matrix. See, basically row matrix is nothing but a matrix which has only one row. We keep on arranging the elements in form of a row, 1, 2, 3, 4 and 5. Suppose there are 5 elements and we have arranged them. We have arranged them in what? In just form of an horizontal basis. So this kind of an arrangement will be known to be a row matrix. Now the question comes, 1, 2, 3, 4 and 5. Whether I should call it a sequence or whether I should call it a matrix. The question to that is, this is a sequence. 1, 2, 3, 4 and 5. This is a sequence, right? I am writing down the elements one after the other on the basis of common difference here. Common difference is 1. So this is a sequence. Then what will be a matrix? In order to identify that my arrangement here is not a sequence but a matrix, for that we usually go with the brackets, square bracket. Okay, square brackets have been introduced basically to identify, to differentiate in between sequences and in between matrix. That is it. Okay, so elements, when you keep on arranging them in a row format, such matrices are known to be row matrix as given here. And now coming back to the column matrix, matrix having only one column is a column matrix. Once again, guys, if I just take in 3, 4, 5, I don't know whether this is a tabular arrangement or a matrix. Then again, we just separate them out with the help of a bracket, a square bracket. Okay, and why only square bracket? Why not circular bracket or parenthesis or flower bracket or something? You can use that if you want. We just go on with square bracket because it is easier. You just have to draw out a line. Okay, if the values or elements are larger, we'll have to go out with some kind of designation here. That might be complicated on that basis. Okay, logical guys. Okay, null matrix or zero matrix. Matrix in which all the elements are zeros is called a null matrix or zero matrix and denoted by 0. Now here guys, you know that this is a null matrix or zero matrix. A matrix which has completely 0 is known to be what? A zero matrix or a null matrix, which is represented using the symbol phi. Now the question comes here. See, 0 means there is nothing here inside. When there is nothing, why is it that we are representing that as a matrix? Correct? 0 means what? Nothing. See, 1 plus of 0 is what? 1. 2 minus 0 is what? 2. So when we add out or subtract anything with this 0, the answer is going to remain same. Then why is it that we are representing these zeros here? Why do we need to even take out this zero matrix or null matrix? The question to that guys is, the value of 0 is unknown to us. Okay, 0 actually has an infinite value, just like pi, 22/7, the ratio of circumference of circle to the diameter. Correct? 0 has infinite value. We don't know what that value is, so we can't just take this to be nothing. Nothingness is everything, like a great person once said, nothingness is everything. Okay, of course I am great too. Okay, I said it, yes. Okay, just so you know. Okay, so 0 guys, it has an infinite value too. So in order to represent that value that we actually have, the value that we don't know, so we can't just neglect it all. We just represent it in the form of zeros basically. Okay, null matrix or a zero matrix, 2 cross 3, 3 cross 3 matrix, we can keep on arranging them as per we want. Now coming back to the square matrix. Okay guys, see, matrix or matrices are basically also divided on the basis of shape they assume on the basis of shape, like a square matrix and a rectangular matrix. Now the question comes as to why do we need to arrange matrices on the basis of shapes? Why rectangular arrangement and why square arrangement? Why not circular arrangement? See guys, here basically if I just focus in, I am to arrange the elements in rows and columns. Correct? If I arrange the elements in form of rows and columns, I can get either a square or only a rectangle. I am not able to get out a circle here. I won't get any other different shape if you just look in, because it is due to the nature of matrix. You can either get a square or you can either get a rectangular matrix. So now when you are getting an square format on a rough basis, when you are getting an square format, whenever the number of rows and number of columns are equal, then you will be able to get out a square matrix. Correct? So on that basis they say when the number of rows and number of columns are equal, such a matrix is known to be a square matrix. Alright? And when number of rows and number of columns are not equal, then definitely it will be what? A rectangular matrix. Correct? It will take out the shape of a rectangle. Length is greater than breadth or breadth is greater than length in form of rectangle, whereas in case of square they are both one and the same equal value. Alright? Now guys, basically question comes, why do we need to distinguish the matrices on the shapes here? Why divide them on the basis of square matrix and on the basis of rectangular matrix? Okay. See, suppose guys we have about 50,000 matrices. 50,000 matrices. And before that, suppose you have 50,000 students or 50,000 employees or 50,000 people. Now you want to distribute something to them. You want to distribute something. So whenever in case of institutes, colleges or schools guys, something or some element or some gift or something has to be distributed, we basically do what? We divide these 50,000 people into different format. Okay, depending on their height, depending on their class sectors, depending on something, we basically separate them. Why we are separating them? Because we need to distribute some 50,000 sweets among these 50,000 students. we can't just keep on distributing them one at a go, because then, like I said guys, order will be destroyed. If there is no order, there will be chaos. Chaos means complete distraction, okay, complete silent. So there will be chaos. In order to maintain that order, we basically divide what 50,000 suites accordingly, as per the classes, as per their heights, or as per their ages or something. We do that. And here too guys, whenever there are about 50,000 number of elements or 50,000 number of data that we have, and we want to study them, in order to study them with order, in order to study them with the proper format, we basically divide it. Out of those 50,000, we do what? We form one group of square matrices, and we form one group of rectangular matrices. So then it will be what? Then it will be divided out, correct? Then it will be what? It will be what, like cutting out an apple. Okay, suppose we have a large data that we want to study. We do what, guys? We basically study it part by part, correct? So that, for that reason, in this format of arrangement, in the topic of matrices, we divide those matrices into different forms, two different type of features here of matrices, square and rectangular. And why only two? I told you guys, there are only two formats which will be available here. One is rectangle and one is square, so that it will be easier for us. Okay, we are just going to take out the division format so that it will be easier. Simplification will be a lot much easier. Now here, if I take in 25,000 square matrices and 25,000 rectangular matrices, once again it will be easy for us, so that we can give this 25,000 to one employee and this 25,000 to another employee, or these 25,000 suites to girls, these 25,000 suites to boys, or something like that. Okay, so basically for that division, so that our study will be easier, our calculations will be easier, we basically have to divide out the data, separate them. And that separation in the case of matrices is done on the basis of shape. Okay, and what that shape is, guys? Shape of a square, shape of an rectangle, of a rectangle. Okay, so square matrix means basically, if you say the number of rows and number of columns are equal, just like an example that has been given here, rows are 2, columns are 2, and 2 into 2, which is basically nothing but 4 number of elements, 1 2 3 4. And here guys, this also is an square matrix, but it has what? 3 rows and 3 columns, so totally there are 9 elements. Okay, now guys, in a square matrix, diagonal from the top left corner to the right bottom corner is called principal diagonal or leading diagonal. Okay, see here guys. See, basically when we talk of a square has 2 different diagonals, correct? Diagonal means what? Diagonals means basically a line, guys, which is connecting the opposite points, not the alternate points. Suppose 1 2 3 4 5 6, these are some set of points here that I have. A diagonal means basically the first feature, a line that is connecting 2 different points, okay, which are not alternate. We are not connecting the points which are side by side. Not alternate here, not consecutive. Okay, not consecutive. We are not connecting the points which are side by side, but we are connecting the points on an alternate basis, if you want, alternately, one after the other, or 2 after the other, 3 after the other, something, so on and so on. Okay, so this point or this line will be an diagonal, and here is the point, the next point are here, there are 2 different points. We are not going to connect them, we are going to connect out some other point, and this will be a diagonal. And here once again this will be a diagonal. So now if you connect all these points, it will be what? Diagonal of a triangle, or we call that particularly to be a median. Okay, so nonetheless guys, coming back to the part of matrix here, it is a square matrix. So in square, what we can draw in 2 different diagonals, 1 2 3 and 4. Suppose this is a square matrix, and here this line, if I draw in case of a square, this will be a diagonal. And here there are what? Elements here 1 and 4. These elements 1 and 4 are known to be the diagonal elements, because they are at the position of the diagonals here, correct? And this particular diagonal in case of a square matrix is known to be primary diagonal or a principal diagonal, because that we take out to be first diagonal. There are 2 diagonals, guys, in square. This we take out to be the first diagonal, and this part here we take this one to be the second diagonal, 2 and 3. This will be what? Second diagonal, or it is known to be secondary diagonal. Why secondary and primary? Because we have to start here, guys. The first element comes here. Basically we have to start here, hence the diagonal from here is known to be primary diagonal, and the elements are known to be primary diagonal elements, okay, or principal diagonal elements. And now here elements 2 and 3, they are basically known to be secondary diagonal elements, because this is a secondary diagonal, first diagonal and second diagonal, hence secondary diagonal. The elements are known to be secondary diagonal elements. Okay, so this is what they have said it out loud here in the part of fourth property. All right. Sorry guys. So rectangular matrix, as I told you, the number of rows and number of columns are not equal, and here there won't be any diagonal, because in case of rectangular matrix, guys, we are not going to go up with the diagonal format. It will be very much on a complicated basis if we do that in case of matrix. But in case of rectangle, we already have diagonals. That is on the basis of shape. On the basis of the study of shapes, when we usually go out with, we take out the diagonals, because geometrically it will be easier. But here in case of rectangle, if you take in, you can't connect these elements here, 2 and 0, because it will be complicated. We might miss out some elements and there might be some mistake on that basis. Alright, so now coming back to the last here, guys, sixth form of matrix, square matrix, in which all elements except elements in the principal diagonals are zeros. Okay, see here, guys. Diagonal matrix we are talking about now. Diagonal matrix. What do you mean by diagonal matrix? See, diagonal matrix, first of all, it is a form of a square matrix. Correct? It is a form of a square matrix. Please don't by-heart this one. It is very logical. If there needs to be a diagonal, it should be a square first, like I told you. Correct? If it isn't a square, there won't be any diagonal. And so on that basis, diagonal matrix is also a form of a square matrix. Now here in this case of a square matrix, guys, the elements apart from the principal diagonal are zeros. A square matrix in which the elements along the principal diagonal, apart from these, all the elements are zero. Such a matrix or such a square matrix is known to be a diagonal matrix. 0, 0, 0, 0, 0, 0. So here, apart from principal diagonal, all the elements are zeros, hence it is known to be a diagonal matrix. Or in the other sense, if you say, only the diagonal has the elements here. This is the diagonal, correct? Only the diagonal has the elements. Such a square matrix is known to be a diagonal matrix. Understood? That is it, guys. So furthermore, guys, those guys who are watching me simultaneously on app, to go through the classes, guys. So now, guys, that will be it for today on YouTube. Those guys who are watching me on YouTube, guys, I understand matrices is a very easy topic. I hope you know that, and please go through this class, guys. I've just told you on the commonsensical basis what are the reasons that we are studying matrix. Okay, so those guys who are watching me on YouTube, guys, do like the video if you are able to understand. Let us know your comments in the comment section. Ask us any doubts if you have. Subscribe to our channel, guys, at Rio Academy. Join us at the WhatsApp group. Join us at the Telegram channel. And do download the app, guys, Rio app from Google Play Store. Of course, the link has been given in the description. If you want to join in for the batch course of PGCET MCA or MBA, guys, contact us at the contact number. Currently, the Lakshya batch, that is the first batch, has been going on. We have started up the topics. I have covered up number of topics. I myself, guys, will be conducting the PGCET MCA classes for the subject of mathematics. Okay, so that will be it, guys, for today on YouTube. I hope you are able to understand. So thank you, guys, once again for joining us live. Thank you. Will be watching me later. Be seeing you again, guys, in the next class. Up till then, have a great time, guys. Take care. Bye, guys.